are a couple of quick tips to help make setting up a MIDI system go a little smoother. First, when making MIDI connections, be sure to match up the notch on the end of the cable with the notch on the jack. These will vary in placement on different products, sometimes up, sometimes down, sometimes to the side. Second, only use cables that are specifically designed for MIDI. Third, be sure you use MIDI cables less than 50 feet in length. Any longer and MIDI data can become distorted and unusable. Also, if you plan to have more than 3 or 4 MIDI devices connected together, you might consider using a MIDI through box, also called a splitter or switcher. This allows each slave device in a system to receive data from the master at the same time. In systems 1 and 2, this really wasn't a problem because there were only 2 or 3 devices. However, each time MIDI messages pass from one device to another, there is a distortion of data and a slight time delay. By the time this reaches the 3rd or 4th device, this may become noticeable and start causing problems. A splitter takes data from one or more sources and sends it to several devices simultaneously, thereby eliminating the problem. Now, open your workbook to System 3A. Let's develop an even more sophisticated MIDI system that includes a master controller, a sequencer, a drum machine, and 2 rack mount tone generators. Let's say one of these is multi-timbral. Remember, that means it can produce several different sounds at once. Again, this master controller could be in any form: guitar, drum, wind, grand piano, even a vocalist with pitch to MIDI converter. Depending on your applications, you might consider a master MIDI controller with several rack mount tone generators to make a powerful and portable MIDI studio. This system also incorporates 2 time-based units, the sequencer and the drum machine. Many drum machines and sequencers will synchronize to a variety of timing signals, including MIDI clock. This means you can also set up a master-slave relationship with devices that work with time. In this system, let's say the sequencer will provide all master timing information. Therefore, we will need to set the drum machine to listen for and sync to the sequencer's internal clock. You can see this is another factor that determines the order of your MIDI devices when laying out a system. Notice that for this setup, we will have 2 different master controllers in the same system. At times, we will use the controller to play the tone generators and to record sequences. During playback, the sequencer is the master controller. The drum machine will sync to its clock, and the tone generators will respond to its outgoing MIDI messages. Therefore, we will use a splitter that has 2 inputs and 4 throughs. Think of the splitter as similar in function to a switchboard operator. All data will be routed using switches on its front panel. Its inputs handle sources of data. In other words, messages from master controllers. Its throughs are connected to the slave devices, passing incoming messages along to several devices simultaneously. A splitter also eliminates the need to physically plug and unplug cables. Everything stays plugged in, and messages pass through it and are routed to the appropriate devices. A splitter is also useful in a system where several devices do not provide MIDI through jacks. Notice that System 3 can be set up in a variety of ways depending on what you want to do. A MIDI controller, a sequencer, a drum machine, and 2 tone generators provide a high degree of flexibility and capability. Later, we'll add the splitter for an extra measure of convenience. Let's try 3 different configurations, all using the same group of equipment. Start with System 3A. Pause the tape now and make the appropriate MIDI and audio connections, where the MIDI controller is the master and everything else is a slave. You may have hooked it up like this: controller out to sequencer in, sequencer through to drum machine in, drum through to A's in, A's through to B's in. This daisy chain will allow you to create music into the sequencer and hear any of the other slave devices while you are recording. However, this setup only allows you to record it doesn't let you play back and hear the music that you've already recorded. So, turn the page and let's move on to System 3B. This will be a playback configuration. To hear music from the sequencer, it needs to be the master. In this situation, we're using the sequencer as the master. Therefore, we don't even need to hook up the controller. That's why it's grayed out. Pause the tape now and fill in the diagram where the sequencer is the master and the drum machine, A and B, are the slaves. Does your setup look like this? Sequencer out to drum machine in, drum machine through to A in, A through to B in. Great, you're doing fine. By now you can probably see how useful it is to sketch things out on paper before actually tackling the MIDI spaghetti. The repatching you just did with System 3A and B would have to be done every time you wanted to switch between recording and playback. However, there is another way to go. If your sequencer provides a feature called echo, or sometimes echo back, you can eliminate a lot of cable maneuvers. Echo is a function that adds a temporary MIDI through to your sequencer's MIDI out. Turn back to System 3A for a minute. If this sequencer provided echo function, instead of using MIDI through, we could connect the sequencer's MIDI out to the drum machine's MIDI in. From there on, it's still MIDI through to MIDI in, through to in. In this way, you can play the controller and record your performance into the sequencer. Since we're using the sequencer's MIDI out, we can also hear what's already been recorded. In addition, the echo feature allows you to hear the part that you are currently recording. This means everything stays connected just the way it is during recording as well as playback. However, some sequencers do not provide an echo function. So, the next step is to add a splitter so we can leave both the controller and the sequencer hooked up. Now turn to System 3C and try connecting the keyboard and the sequencer into the splitter as controllers. The drum machine, A and B, as well as the sequencer will all be slaves. Before filling in the diagram, here's another important point to keep in mind. Be aware of accidentally creating a MIDI loop. This occurs when a device's MIDI out is routed back to its own MIDI in. This causes everything in the loop to lock up and stop working. Should this accidentally happen, simply power all the units down. Then trace the MIDI signal flow, make the appropriate changes, and turn the power back on. This situation is more likely to occur when using devices that split or merge MIDI messages. In this system, watch the sequencer. An important factor is the flexibility of our splitter. The splitter in this system allows you to store several different configurations in its memory. We'll want one setup for recording and another for playback. The sequencer will be a master in one system and a slave in the other. Remember, everything will stay hooked up to the splitter and it will handle the routing for you. With this in mind, pause the tape now and take a moment to fill in System 3C in your workbook, making the appropriate MIDI and audio connections. As your MIDI system grows in capabilities, the options for connecting and using each component also increases. Therefore, this diagram presents just one way to hook up System 3C. In this case, connect the controller's MIDI out to MIDI in number 1 of the through box, and the sequencer's MIDI out to MIDI in number 2. These will be our two master controllers. Next, connect through number 1 to the drum machine's MIDI in, through number 2 to A's MIDI in, through number 3 to B's MIDI in, and through number 4 to the sequencer's MIDI in. The splitter will store several different routing setups, and we can recall them at the touch of a button. Therefore, you can program it to recreate System 3A for recording and System 3B for playback. This way, we eliminate a potential MIDI loop. If you already own a splitter, on some units the through jacks may be incorrectly labeled MIDI out, even though they function as MIDI throughs. Just something to look for. Now, back to our system. What else do we need to do to get things working properly? First, set the drum machine sync to MIDI clock. This allows rhythm parts in the drum machine to play back in time with music data from the sequencer. The drum machine will also receive start and stop commands from the sequencer. In other words, pressing start on the sequencer will also start the drum machine, which will play back in time with the music. Pressing stop controls the sequencer as well as the drum machine. Well, congratulations. Once you've made it this far, you're well on your way to untangling MIDI. You can now begin designing and setting up your own MIDI system. As you do, keep in mind the 8 important system setup guidelines listed in the workbook. These will help make things go more smoothly.